My name is Ashley Ann McLeish. I am a member of AIA Orange County. It is such a pleasure and an honor to be able to present to all of our Zoomers today who are listening in. I have here with me Tony Hobbs. He and I both work here in Southern California with TNEMIC. I am newer though. My expertise is in resinous flooring and coatings of that nature, but Tony Hobbs has been a staple here in Southern California for how many years, Tony?
35 years.
35 years. So, and he has this amazing English accent, which makes it much easier to listen to. So I'm going to have Tony Hobbs do the presentation today for the most part. So you won't have to see me going in and out and blurring in and out. But I just wanted to thank you so much for letting us come here to present to you and to provide you AIA credits on our presentation, The True Value of High Performance Coatings, and allow Tony here to discuss that a little bit more in detail. Tony?
Thank you, Ashley.
Thank you.
And thank you, everybody, for joining us.
If you'd like.
I'm going to talk about the true value of high performance coatings and maybe give you a different insight, a different thought process. But first, I just mentioned TNEMIC. This is an AIA accredited program, so you will get one continuing educational unit. But briefly about TNEMIC, and then that's where I'm going to kind of stop. We're the largest held private coating company, and we've been around since 1921. So we're a long-established company that's got a lot of history, and you've probably heard of TNEMIC. TNEMIC, a little known fact that we just discussed, TNEMIC is cement spelt backwards. So our very first primer was a cement-based, Portland cement-based primer, and that's where the name TNEMIC came from. A little bit about myself. Prior to being with TNEMIC for 35 years and prior to emigrating to the States from London, England, I was an engineer. And the last company I worked for that has since moved over here about 10, 15 years ago is Arup. They used to be called Ovarup, and now they're Arup Partners. And that's who I used to work for. So with that being said, let's carry on with the topic of today, the true value of high performance coatings. Again, this is accredited. You will get one unit for this. Copyright materials, but you can use this how you want. The course description is going to tell you how to participate, how to evaluate the true value of high performance coatings, life cycle costs, importance of selecting coatings based on performance rather than initial price. This may help you to evaluate in the future. So you can read that. We're going to discuss selection of coatings based on performance, understanding life cycle cost, and how to incorporate cost methods into your specifications and design criteria. And most importantly, how to ensure coating performance utilizing test standards in your specifications. So here's what the industry thinks: coating perception and reality. Better performance is more expensive. You've probably all heard that before. I'd like to be more selective with the coatings I specify, but my hands are tied. I have to have multiple manufacturers in the spec. That's the architect. The painting contractor, I'd rather use a quality coating, but unless it's a level playing field and everyone is bidding apples to apples, the job is going to go to the paint manufacturer with the cheapest price. We've all heard that. Are you seeing a common thread? The industry has primarily focused on price per gallon as a basis for coating selection. And that's a very important thing I want you to remember here. Price per gallon. Everybody goes, oh my God, it's too expensive. The pressure to reduce selling price and remain competitive will compromise performance. In a specification that includes multiple manufacturers and provides various levels of quality, the lowest performing, least expensive product will be chosen. The reverse is more often the case. cheap is expensive. If you look at this picture here, this is a project actually in Manhattan Beach. This is the shot primer. They didn't follow the specifications. They didn't follow the surface preparation, and they just put on a primer. And by the time the building was erected, I was called out to say, what's gone on here? Well, the specifications weren't followed, and here's the case. Cheap is more expensive. The issue with cheap, lower performing, less expensive coatings, lower resins, lower ingredients, lower coverage rates, lower film build, and then you will get failures. Importance of performance. Performance, not price, is the key objective. So performance will help extend painting and repainting cycles. It will give you substrate protection, aesthetic performance, and asset preservation. Your client will be pleased with the performance high-performance paints can offer. So why is cheap expensive? Well, you got the initial application cost, the installed cost, and then you get your life cycle cost, and that yields life cycle cost of the coating system. So life cycle is a function of two variables, cost of installation and the life of the coatings. But here's something that breaks things down and makes it a little bit more clearer for you. Here are all the components of the installed cost. Surface preparation, material, that's the paint, labor, equipment, supplies, disposal, environmental related impact and costs, overhead profit, asset downtime, opportunity costs. So if you look, material cost is such a small component of the overall installed cost. High performance coatings are, or where it says can be, but they are more economical than lower performing paints because a poor paint system with lower upfront cost will require more frequent repaints than our higher performance system. This particular project is the Amazon spheres in Seattle. Hot, humid environment in there, and all the steel had to be protected because of the severe exposure conditions. You couldn't have a high profile project like this knowing that paint was going to fail prematurely in a matter of 2 to 3 years. Some of these slides I'm going to not dwell on, but let's look at the 25-year life cycle cost. Alkyds, those are oil-based paints. You really don't use them anymore, but you know, you're going to get 3 to 5 years service, 3 to 5 years of service. Acrylics, maybe 4 to 6 years of service. And on the right, you see number of applications for repaints, that is, when we mean number of applications. Polyurethanes, they're the meat and potatoes of the industry. They're pretty good. You're going to get 7 to 10 years. You might get a little bit longer, but not gloss and color retention. Maybe 3 paints, 3 repaints. Polysiloxanes, maybe 10 to 15 years. That's pushing it a little bit because there's limitations on colors with that. Maybe 2 repaints over the life cycle. And a fluoropolymer, which is a field applied kynar, 20 to 25 years. So if you look at the cost of the application, so if I went with an acrylic versus, say, the top end range of a fluoropolymer, so the cost of application is, say, 34,000 and change. And the fluoropolymer, let's go to the top end, is 82,000. But I'm going 20 to 25 years. Whereas the acrylic, I'm going to repaint 3 to 4 times. So the final cost on the right is what your client is going to end up paying. That's your life cycle cost.
Hey, Tony.
Yes?
We do have a question, and I see John has his hand raised as well. John, I'm going to think it's the same question, but if not, go ahead and come off mute. So John's question is, what systems work best inside an auditorium with an acoustical metal deck system?
Okay, so if it's a decking system, that may come out pre-finished, but it's the structural steel beams that you'd want to protect. And I'm going to speak generically here. Even though natatoriums have increased ventilation up there, they still get some humidity. The vapor area is the most corrosive area. So if I was to put anything up there, the prime coat would be zinc. Zinc, without question, is the best corrosive primer there is. And then you can go with an epoxy, then a polyurethane. That's what I would put in a natatorium ceiling. So, and here's another life cycle cost evaluation. So surface preparations, that's critical. That's surface preparation, whether it's a 3-coat alkyd or whether it's a zinc epoxy fluoropolymer. I've purposely put the fluoropolymer system in there because it's the most expensive, but it's the longest life cycle cost. So I'm trying to show you from one end to the other. So you'll see an application cost, and these are just guides. I could be off. Square foot cost, 5-year life cycle cost, 92 cents versus 20-year life cycle cost at 34 cents. So you can see all the other factors there. Surface preparation, application is the big ticket item. And even though the material costs might be a little bit different, that is not the driving factor. And as I said, life cycle is not really affected by increasing or decreasing the material cost. Even if the material were free, the net effect on life cycle would only be reduced by 0.07 cents to 11. However, increase in the service life reduces life cycle cost by over 70%, even when the material is increased by 60%. So really what I'm saying there is life cycle is an important evaluation, and it may not apply on every project. Sometimes projects don't require this extended life cycle, but they will leap out at you if you need it. Again, here's some more life cycle cost evaluation. I'm just going to let you read that yourself. I'm not going to read it to you. Again, from oil-based alkyds, which we don't use anymore, I should really take case study 1 off, and we should start with 2 and 3. And you can see that, you know, the life cycle cost per year is so much lower. The material costs and the labor costs are very similar. But here's something that's really important too that we don't discuss when we're talking about materials and good materials, bad materials, average materials, is why surface preparation is so important. This is actually lower, but 60 to 80% of all coating failures are caused by completely or partially by inadequate surface preparation. And that's even over galvanized metal too. This is very important, and I can't emphasize enough why surface preparation standards should be in your specifications. They probably are, but there are standards that you can refer to for spec writing. SSPC, the Society for Protective Coatings, and AMP, the Association Material for Protective and Performance. These are industry recognized standards that are not unique to Tnemec, but will help you with your specifications. And these are some of the widely accepted standards. They all have a designation and they all have a degree of cleanliness, and that's what you should put in there. This is for metal, obviously. And there's visual standards that will help you know. So like for exterior steel or steel in a natatorium ceiling subject to harsh environment, the minimal surface preparation standard should be an SP6 commercial blast clean. That should be your minimum standard. And SP11 should be your minimum standard for touching up welds in the field. And I'm going to show you these visuals now so you can see what they look like. So there are visual standards, as I said. So SP2. So if you get raw steel in the mill and they're going to say, I'm going to hand tool clean, that doesn't remove the rust. It removes loose rust, loose mill scale, but it's still rust is there. So you don't want to specify that standard for exterior exposed steel, steel that's subject to harsh environment like a natatorium ceiling. SP3. Now this is a power tool clean. Gives you a slightly better degree of cleanliness, but mill scale rust and coating, if it's adhered and cannot be lifted with a dull putty knife, remains. SP11. Now this is the standard that we like for touching up of shop primers. And notice the difference between SP11 power tool clean to bare metal, and look at the weld down below, to SSP3 power tool cleaning, but without the emphasis of bare metal. This leaves rust, this removes rust. So the welds are often overlooked. You get this nice high performance job, you get the structural steel coming out, you've got a great system specified, you've got a zinc primer, and then the welds are not touched up how they should be. And then you've got the weak link around all the welds. Here's an SP6. That's the commercial blast clean that the steel fabricator should use for any high performance system. And it's the removal of all oil, grease, dust, dirt, mill scale, very important. You must remove mill scale, rust and coating. And there's a little bit of discoloration after the sandblast. Brush off blast cleaning. It is what it says it is. If somebody says, I'm just going to brush off blast clean the steel in the fabricator shop, well, he's still leaving rust and mill scale. This standard white metal blast is generally done in industrial environments, bridges, tanks, petroleum plants. They like to go to a higher degree of standard for cleaning their substrates. And actually, the cleaner the substrate, the better the paint will last. But this is more of an industrial grade standard. But I just wanted to show you that white metal blast is, in fact, what it means. Near white metal blast, this is an industrial grade as well. It's just a higher degree of cleanliness than a commercial blast clean done for immersion and or severe environments. SP16. Here's an interesting one. If galvanizing is not prepared correctly, in accordance with the standards as set by the galvanizers, then you're not going to get paint to stick to galvanizing. And it goes through in their duplex system. If you were to read their duplex system, and we'd be more than happy to send you the pros and cons of galvanized steel when it comes to painting, it says if it's passivated or you can't weather it, then they recommend sweep blasting with a fine abrasive. Well, we all know that galvanizing is not going to get abrasive blast in the field. It's not practical, it's not feasible. So straight away, we have compromised the recommended surface preparation for galvanizing. But galvanizing has its place, pros and cons, and on a separate subject, we can send you pros and cons of galvanizing versus a zinc-rich primer. Now, along with surface preparation of a metal, there's also surface preparation of concrete, which we need to adhere to and follow, especially if we're doing resinous flooring. Resinous flooring has distinct standards for the resinous flooring to adhere to. And again, they are visual standards as well. We need a surface profile. And depending upon whether it's thin film, thick film, whatever the system is you've specified for a resinous flooring, flake, quartz, solid color, urethane, cement, depending upon your project, surface preparation is critical for resinous flooring. And these are the standards that you would specify. And again, basically these visual standards from CSP1 to CSP10, that's just the different aggregate, the different profile. So when you're doing resinous flooring, you want to put surface preparation standards in besides the coating selection, the same as you would for steel. So let's examine the quality coating system. We got the value of performance. How long should a protective coating last? And if you specify the right system, I'm just going to show you, like, here's 15 years of performance. If we can perform in Philadelphia in a harsh environment with a primer, good primer, intermediate coat and finish coat with a urethane, then you get projects like this. New York, again, 15 years of performance. Notice the key is the zinc-rich primer. We often overlook primers, but primers are key to long-term corrosion protection, and the finish coat gives you your gloss and color retention. Yeah, we actually do artwork too. This is 15 years. Now, here's an interesting one. On our industrial side of our business, we have two divisions within Tnemec. We have specialty architectural and we have industrial. And Ashley and I do both. Here's a water tank in Hawaii. Very harsh environment. The humidity, the sun, it's so fierce. Here it is after 11 years of performance. We still got the same gloss and color retention with a fluoropolymer, which is a field-applied kynar. Here it is almost 20 years later. Same gloss and color retention. So performance matters when it comes to selecting high-performance paints. Here's a bridge in Pittsburgh, 30 years old. So the cost of failure. This is interesting. So the failure is very, very critical and expensive. I mean, doing it right the first time can affect the cost. I mean, can you imagine what it costs to replace a coating that fails early? I mean, the downtime, the bypass costs, the legal costs, the protection, the containment, is probably going to be 4 to 5 times as much, and the labor is going to be 10 times as much. Oh, here's another one, 25 years old. So ensuring performance in your specifications. So identify the coating, measure the performance on standardized tests, and specify based on composition and standardized test methods. What coating do you want? And there's various ones out there. Oh, excuse me. There's various ones out there. I'm not going to, you can read this, you know, we're going from the top alkyds, which I need to get rid of that slide. We don't have them anymore. You're going from acrylic, polyurethane, polysiloxane to fluoropolymer. I beg your pardon, I'm stuttering there. And they're the better systems with the zinc primer. So they're the better finish coats in order. Exterior testing. Every reputable manufacturer should be able to give you exterior weathering testing to show how well the coating will perform. We do both. We do Florida and we do Arizona. Different parts of the country have different weathering and exposure conditions. That's why we do Arizona and we do Florida. Dry environment versus hot and humid environment. You really can't see this. This is a real world performance. The top layer says unexposed, and but it's just showing you performance, but it doesn't come across very well on this screen. Again, real world limitations. High performance coating systems could take 20 years before visible coating degradation. That's a very important point there. Accelerated testing. So again, reputable manufacturers will have testing that you can refer to. And they are very harsh tests. It's accelerated weathering. We have QUVA, closely simulates natural sun. And IMAQUA, this is a more harsher one. And that's what reputable manufacturers will test with. And here's an example. So 10,000 hours of QUVA exposure on darker colors. On the left is a polyurethane, the bread and butter of high performance coatings, but with deep colors, they're limited. And once we exposed it, we did our 10,000 hours exposure, you could see that the dark colors will fade. Whereas a fluoropolymer on the right will give you 20, 25 years gloss and color retention. So some projects may need a polyurethane, some projects may need a fluoropolymer, and color makes a difference too. Accelerated weathering, we go through all that to make sure that we don't get corrosion. And here's what accelerated weathering will do. So you get an unprimed steel plate on the left, alkyd, oil base. There's still some of those primers around. After 500 hours, you're seeing it starting to corrode versus an epoxy primer, which is very good. After 4,000 hours, minimal undercut corrosion. 8,000 hours is 1 year. And then you get a zinc-rich primer after 10,000 hours, where we scribe, where we cut the plate, hardly any corrosion. And here's a zinc primer, just the primer by itself, exposed to salt fog after 30,000 hours. And the scribe, there is no minimal undercut corrosion. That's why when you're doing exterior metal or metal that's in a natatorium with a humid environment, the zinc primer is key to long-term corrosion. The finish coats give you the gloss and color retention. And we can give you real-world results. Isn't paint all the same? That's what you're going to hear. Well, I specified a urethane and I've got a submittal for a urethane, so it must be the same. Well, let's look at how many formulas you could get. So most high performance paints are two-part mix. We've got a part A and a part B, and it's combined. Let's just assume part A has 10 ingredients: resin, pigment, additive, solvent. Let's say each ingredient has 3 versions: good, better, best, economical, low performing. 10 ingredients times 3 versions, you've got 30 options of resins to make paint. 30 options times 3 suppliers, now you've got 90 options when you're formulating paint. We'll skip this slide, but I think you understand where I'm going from here. 90 options plus 90 options, you've got 180 possible formulations to make one paint, a urethane or an epoxy. So that's why testing and evaluation of what you're specifying is very important, because just because it says a urethane, how good is it? VOC regulations, we're fully VOC compliant. Our coatings meet the stringent one, which is South Coast AQMD. All our products are VOC compliant with South Coast AQMD. And if you can meet South Coast AQMD, we can meet any VOC zone throughout the country. So life cycle cost is more a function of life expectancy of a coating rather than the installed cost. Quality will vary from product to product, but can be predicted by using ASTM tests and specify quality to minimize life cycle costs. High performance products, although more expensive, and that's only material cost, not labor cost or mobilization cost, will provide longer long-term aesthetic performance and lower life cycle cost. It's proven, and there's too many projects nationwide going back 30 years in harsh environments that have proven this. So when you specify high performance coatings, all finishes should be in Division 9. However, all primers should be specified in Division 5. Very important. If you say in Division 5, refer to Division 9 for high performance primers, Oftentimes, the steel fabricator do not refer to Division 9, and it just says shot primer, and you get a cheap shot primer. Once you get a cheap shot primer applied, it doesn't matter how good the finish coats are, your coating system is compromised. The primer is key, and that's why you really want to put the primers in Division 5. Painting contractors will submit one manufacturer. A single manufacturer submittal covering all systems, regardless of performance. And they will sometimes do that. So, you know, if there's a lot of commercial paint on the job, which may even dwarf the high performance section, they will try and submit that, and hopefully they can sneak it through. But the contractor is required to meet, you know, but not necessarily exceed the specification. And the contractor, not all, but some, is banking the specifier doesn't care to know the difference between traditional paints and high performance paints. So you really want to check your submittals when they come in, especially if you specified high performance coatings for a specific project. And it's critical for the owner or yourself as architects to establish them in the minimum performance you are willing to accept, and then specify it. Specifications. Again, by utilizing Division 9, you can define the scope of work and differentiate critical design elements. So 09600 high performance coatings, 096723 fluid applied coatings, resinous, but coordinate with Division 5 subsections. In these 3 subsections, list the primers. Don't say refer to 09600, or don't do that. Put the primers there. Again, primer is key to long-term corrosion protection. And if it's not listed in the appropriate section, I can guarantee, and you've probably already experienced this, you're going to get a cheap primer. You'd be surprised at how many manufacturers of primers there are nationwide. All they do is primers. Some I've never even heard of, but they just want to sell primers. The fabricators want to just put a holding primer on and send it out to the field. And again, everything is compromised, especially if you're looking for a performance-related system. Again, specifications. Determine key performance tests for evaluation purposes. Obtain test data from manufacturer. Evaluate test results. And list only the best performing products. If you are dealing with reputable manufacturers, they have all this. They will be able to give you test results, case histories, data, and make the right recommendation for you. And incorporating standards into your specifications, your client is assured sustainable, high-quality products. If we list all the testing, the weathering standards, salt fog, prohesion, all the standards that are out there on the market, you will get a quality paint system. And every reputable manufacturer has all this testing. If they don't have it, that would be a concern. So coating environments. So high performance coatings are used on almost every substrate: steel, aluminum, cast iron, galvanizing, non-ferrous metal, wood, concrete, masonry, stucco. Project types. High performance coatings are used everywhere. If you read the list there, every project on this list we have been involved with in one way, shape, or form. Question, there's natatoriums on there. So there you go. And maybe not a large portion of the project, but a critical portion of the project where performance and aesthetics is critical. If you can paint a high-rise building like this in Chicago, bright red, and this was a repaint of aged panels. We do a lot of refurbishment of Kynar panels. If you can paint a building like this, you better make sure it stays red for a long time and sticks to the building. So we have history all around the country. Here's another one, the Forum, more local to us. This is 10 years old now. And the columns, the Roman columns, the white, that's an elastomeric coating. And the red is a fluoropolymer, the field applied kynar fluoropolymer, like the Chicago building, because they didn't want the red fading. And, you know, you're not going to do a retrofit and repaint of an existing building and have the colors go, you know, within 3 to 5 years. Processing and manufacturing, high performance coatings, healthcare facilities. We do a lot of healthcare facilities. We do a lot of resinous floorings and we do a lot of wall coatings. But resinous floorings come in quite a bit there. So because they have to be subject to frequent cleaning and washdowns. So it's aesthetics and performance in healthcare facilities. Educational facilities, the same. We do a lot of educational facilities, you know, classrooms, locker rooms, gymnasiums, natatoriums. Correctional facilities. Now, of course, this is where we do a lot of resinous flooring and wall systems. You have to have coatings that are going to last. Once you move the inmates in, you can't take them out to repaint if something goes wrong. So not only is performance, but it's aesthetics as well. So in this particular area here, we did the floors, the walls, all the metal. It's tough environment. And you know, the only difference between a correctional facility and an educational facility is with an educational facility, the inmates get to go home at the end of the day. That's the only difference. Transportation, a lot of interior and exterior steel and masonry. All across the country, they're subject to severe environment, New York, Denver, Midwest. Oh, here we go. That's a natatorium. So what we were talking about earlier, the gentleman that asked the question, I would imagine that the decking will come out pre-finished, but it's the structural support, the joists, where you're going to get the extreme exposure to vapors. Now, I do know, and we all know, that there's much better, as I said earlier, ventilation than there ever was, and you're not getting as much condensation settling on the structural steel beams. But nevertheless, you know, it is harsh up there. Heat rises. You are going to get humidity up there, and the vapor area is very, very aggressive. So here is a prime example. If you're doing an natatorium, besides the changing rooms where you might have resinous flooring and the walls for cleanability in the changing rooms, the structural steel support above the pool area is a prime example of where you would need a high performance coating, because again, you don't want it failing and you don't want to go back in a few years' time. Can you imagine trying to scaffold this and repairing a coating that's failing or rusting above a pool? Parking garages. Museum. Now, here's an interesting job. This is LACMA. We were originally involved with this, and somebody said, oh, we're going to go with a cheaper paint. They went on the cost of the paint, not on the overall cost or life cycle cost. And it's a bright red. So we lost the job. And I said, really? And they said, oh, no, we got a company, and they said the red's gonna last. This is a museum, so obviously high profile, major feature. It faded 3 years later. The red turned pink, and they called me back out again. So then they had to repaint it again because the corrosion was fine. There was no corrosion. It's just the aesthetics. And they called me back out and said, okay, we got to have a red that lasts. And the interesting thing is, when I met with the architect again and the owners and the owner representative, they said to me, Tony, when they called me out and showed me what had happened, they said, first of all, we don't want the first words out of your mouth saying, I told you so. And that's, and I did, I told them so. So anyway, so if you got bright colors, a fluoropolymer is the way to go, because A urethane is good, as I said, but they're limited, and polysiloxanes are good, but they're limited with bright, vibrant colors. So if you've got a high profile project, an entrance area, or something that's of really high profile and you're choosing bright colors, fluoropolymer is the way to go. It goes back to that tank I showed you in Hawaii, where 20 years later, you got gloss and color retention. But of course, you need the primer as well. And of course, resinous fluorines. There's so many different types of resinous fluorine. Just because a client says, I want a resinous fluorine, well, do they want solid colors? Do they want flake? Do they want quartz? Is it in a kitchen where there's a production kitchen where they got thermal shock, hot oils, fat, and grease being spilled on the floor? So if somebody says, I want a resinous fluorine, there's a lot of questions to ask on types of resinous fluorine too, depending upon the exposure, design intent, and aesthetics. So here's some important points. Mother Nature will always win. And high performance is obtained through intentional product formulation. Not all products that share the same generic description as I've shown you will perform the same. Just because you specify a urethane or a fluoropolymer or a resinous fluorine or epoxy wall system doesn't mean they're all the same. If you remember the bottles and the amount of formulations that you could get with cheaper resins, but people could say, yes, I'm giving you an epoxy without verifying the testing or the performance, it may not be the same product. And exterior high performance coating systems perform best when they are part of a complete system. Remember when I said coordinate division 5 with division 9 for steel coating systems? The primer is so important. If you don't get the right primer, the right surface preparation, the whole system is compromised. Doesn't matter how good the finish coats are, doesn't matter how good the gloss and color retention is, your corrosion is going to be severely compromised. And high performance coatings provide long-term substrate protection, aesthetic performance, and most importantly, lower life cycle costs. So write your specifications around minimal acceptable performance criteria. And again, reputable manufacturers have these. If you want to call Tnemec, we'd be happy to help you. If you have a favorite supplier you like to deal with, call them and they can help you. And make sure that your coatings meet all the VOC limits. We do, but again, most reputable manufacturers should do that. And we can all help you write a good specification dependent upon your project needs. And that, ladies and gentlemen, concludes the presentation. And now I'm open for questions. Ashley and I are open for questions.
If you don't mind me sneaking back in here, do you think we can open this back up again?
Yeah.
There we go. Well, we may not have quite a few questions, but Tony, can I ask you a question?
Sure.
So talk to me a little bit about baked on paints versus the products that we provide, like Flow-N-R, that can be done in the field.
So a baked finish, what you would do on your curtain wall systems, on your panels, on structural steel, you would never do a baked finish. The only time I would do a baked finish on metal, if it's an intricate metal design, like perforated metal or wire mesh. You're never going to get protection on wire mesh or perforated metal because you can't get paint on all the edges and angles. Paint can't protect what it can't reach. So if you're doing perforated panels, don't paint them. Do a baked finish over an aluminum substrate. Wire mesh, get that pre-finished. Don't say you're going to paint it because paint can't protect what it can't reach. But factory finished panels are used all the time, and they're a great way to go. We're really talking about structural steel, architecturally exposed structural steel, interior steel, handrails, stairways, that type of system.
Okay. Thank you so much. I appreciate that. I find that often that is a question when we are in person that is asked of me. I don't know about you, but that
Yeah.
comes up often.
Any other questions that we can assist you with, or hopefully help you with, and help you get a better understanding of the value of the difference and that performance matters?
Yes, there is a question, a new one that just, excuse me, came in. Is Endura Shield a great paint for exterior applications?
Yes, Endura Shield is a polyurethane. So that's, instead of going on to the fluoropolymer is for use where high profile, really, really high profile projects are being used and they're exposed to public day in and day out, and you want the longest life cycle cost. But Endura Shield is a urethane coating, and it is the workhorse of the industry. Urethanes are very, very good. So yes, so like for a natatorium, I would put up in that ceiling, I would go a zinc primer, epoxy intermediate coat, and Endura Shield or urethane top coat. I wouldn't necessarily go with a fluoropolymer on the inside of a natatorium because I'm not subject to extreme UV attack or things like that. So it depends on that. But no, that's urethanes are a good workhorse for the industry.
Tony, talk a little bit about, as an architect, if I'm doing a tenant improvement and I'm going to be doing a recoat, what is the process of that, and what does that look like for my specification?
So if I'm doing a tenant improvement, you may not need Tenemic. It's a good question on offices. I wouldn't use Tenemic on any offices, any office interiors, any exposed metal in the ceiling decking. It's in a controlled space. You're not subject to elements or abuse. I would go with a good grade commercial paint for all office tenant improvement. There are plenty of manufacturers out there. But if you're doing a tenant improvement and you've got an entrance canopy, which everybody's going to see every day, then maybe the entrance canopy could be the high performance coatings. And that would be your consideration. For tenant improvement, I don't think you need a high performance coating.
What if I'm looking to recoat steel outside for like a storefront?
Oh, storefront, we do that all the time. So when the mullions faded and old, we do mullion repaint, and they normally go with the fluoropolymer. The surface preparation is critical, but we would do a test patch because the aluminum or anodized aluminum is slick smooth. So we have to have an adequate anchor profile to make paint stick. Now, when you do repaints over a factory finish or a mullion, we always want to do a mock-up, and the mock-up will determine the contractor has done adequate surface preparation. Remember what I said earlier in the talk? Surface preparation is critical, and it's even more critical on repaints. You've probably all worked on a job where you've had a repaint and the paint just peels off. That's not the paint's fault. It's just there's inadequate surface preparation. So repaints, it's very critical that adequate surface preparation is done. And secondly, on any repaint, call us out and we will evaluate the surface to make sure that the right repaint specification is put together. No two projects are the same. No two repaints are the same. So repaints, you really want eyes on it and get a customized specification.
Hope you don't mind me asking those questions. I just find that those are often the questions that we get that are coming in, in our emails, and then we get calls on. So.
And thank you. That is good to ask those questions. I actually have one for you. It's a little off the side of what you would typically talk about to the architects, but it so happens I'm on our HOA board. And through the years, where garage doors have been repainted, and what they did for many years was spot paint them. Oh, these are the worst, we'll only do those. That was pre my time. What happened somewhere along the way was an extremely bad paint job, and those doors are trash. Every time you repaint, no matter what you do, they just bubble back up. can you actually remove paint back to the original panel, all the way back to it, prime, and then paint again? And if so, is there a spec that should be followed for the type of paint?
Oh yeah, you can repaint anything. Anything can be sanded back to the original substrate. All failing paint can be removed back to the substrate. Anything can be done if you've had multiple repaints and they're all failing. The question I would ask though is, on something like that, then the question I would ask is, that's labor intensive there.
Yep.
The paint is going to be easy, and there's not a large surface area, but it's going to be very labor intensive to remove all that failing paint on a garage door or multiple garage doors. So would it be cheaper to get a new door? And
Yes, and
guarantee
that is what we learned. We did one test door, and when we worked out the cost to do this compared to just get a new door and repaint, it was cheaper to get a new door.
Yeah, and I had the same thing with I was called out to a job 2 years ago in Beverly Hills, and they wanted to repaint a parking garage, and that was fine. The concrete, the masonry, that was fine, but they wanted to repaint the louvers and all the angles and the edges and the louvers and this and that. I went, oh my God, I said, just replace them. I said, because the amount of work involved of trying to strip all this paint that's failing. So yeah, sometimes it's too expensive, and then you're not necessarily getting a guarantee. But whereas on what you just found out, go for a new door with a
yeah, it's unfortunate. We want to do the right thing for our environment, and sometimes it just doesn't work.
Yeah, and that's where you'd get a baked finish on those doors. A factory finish on those doors is the way to go.
Very good, thank you. Any other questions? You know, you basically have ended your program. So for AIA, you have taken care of the things that they need, which is more generic. If there is anything you want to talk about, specifics, dynamic, anything related, maybe that's a specialty that you all offer, please go ahead and do so.
Sure, thank you. So now the AIA presentation's out of the way. I'm just going to tell you about Tnamic real briefly. We've been around since 1921, and we have a coding for every substrate, every exposure, and every project type. And we're very proud of that. We have a great reputation in harsh environments, but basically what is high performance coding? It's paint. You would never tell the difference looking at a commercial paint side by side to a Tnamic paint. It's just the performance and the aesthetics. Now, what we can offer is we at Tnamic kind of do everything. We're kind of the tech rep, the architectural rep, and the sales rep. So we don't just call on architects and then have a different division call on the contractors. We are like a go-to source. So if you call us and we help you with a specification, and then the project's here in this area, you're also dealing with us who's dealing with the contractor. So you will see us in your office and you will see us on site as well. So we kind of like to embellish and do everything hands-on, become part of the team, as opposed to having an architectural rep and a paint rep that just deals with contractors. So I think the service that we can offer may be more beneficial because we want to become a team member for your projects.
And our team is credentialed and has different level of certifications to be able to support you on your projects. As Tony has said, from the top down, we get to be a part of the vision that you have and the intention of your project, all the way down onto the field, which is most important, right? Because you are intentionally putting in a high performance coating, and we want to make sure that that intention is seen, and that your project is successful in a true partnership. We are a national company as well. So if you are creating projects that are on the East Coast, we are very capable of being able to support your specifications here and also giving you local service wherever that project is as well.
Yeah, that's a good point. I mean, because many architectural firms have multiple offices, and I'm working with one right now. The job started in San Diego, got punted to LA, and then it's now in the San Francisco LA office is coordinating the project. So we're hands-on. And secondly, many Tnemic reps are NACE certified, AMP certified as coding inspectors. So we are tech reps as well. So God forbid something goes wrong, we're out there in the field. And if it's a repaint, we're the ones that go out and evaluate the substrates to see what would need to be done. So we're a hands-on representation, and we like to assist any way we can.
Correct. And the other thing that I just have to say is that I am newer to Tnemic. I'm in my 10th month in October here, but I was brought on with the intention of really assisting with the flooring side of what Tnemic can offer. So my background is heavy in poured resinous flooring, and we do have a wonderful line of products, as our competitors do, that can support pharmaceutical, education, veterinarian kitchen, and things of that nature, for your specifications and for your projects and the needs that you have. So I'm here to help, and also in the architectural side as well.
And as Ashley said, what I mentioned earlier about resinous flooring, it's worth repeating again, that if your client wants resinous flooring, we can help. What does he want? I mean, or she want. There's so many different types of resinous flooring depending upon what you're looking for. And we can help you design that resinous flooring depending upon your project, because there's so many.
All right, well, thank you. This was an excellent program, and we greatly appreciate your support. Okay, thank you
so much for having us today. We really
Thank you,
appreciate it.
everyone.
It's been our pleasure.
Yes, thank you
Yeah,
very
great.
much.